Hi class, in this lesson we're going to take a look at absolute value graphs as they deal with piecewise functions. Specifically, we're going to take a look at this formula. This is the standard form for a function that's an absolute value graph. Now the biggest difference we're seeing is that last lesson we had parentheses squared for a quadratic. Now we're looking at absolute value bars, which are these two bars right here, and it creates a V-type graph. We'll see what that looks like in a minute. But let us highlight what these different letters do. Well, notice it's an M in front now instead of an A. M, hopefully you remember from graphing lines, represents slope. And then here are B and C are very similar to H and K, which make up our vertex. Okay, so we're going to see how those work in our graphs of absolute values here. So our steps are to first determine the vertex, and then to use the M to determine the next point from the vertex by counting rise over run, and then reflect that point. Okay, so we'll work through that here on this first initial graph. Now this is the standard absolute value graph, the parent. This is the parent function, which means that all other absolute value graphs actually shift from this one. It's just a translation of this particular graph. Now this is still in the form y equals m absolute value x minus b plus c, but it doesn't have anything in front, which means there's really a 1 for the m. There's nothing on the inside, which means b is really a 0, and there's nothing on the outside, which means c is really a 0. Which means my vertex is at 0, 0. Okay, so I go ahead and put a dot at 0, 0. So that was step 1. I determined the vertex at 0, 0. Now I use the m. Okay, so the m is 1 here. So that means I go up 1 over 1. Just like counting slope for lines, I go up 1, rise 1, over 1, put a dot right there, and I can continue up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1 forever. Now it said reflect that point. That means I reflect it up 1, left 1 also. Up 1, left 1. Up 1, left 1. Okay, and up 1, left 1. Now where we're reflecting it is if you drew a line down the middle of the vertex, which is the y-axis, you're reflecting these points over here. Okay, so these points you can see are reflecting, okay, across there. But I'll erase those lines because it just makes it confusing. Now if I connect these dots, you should come up with a V shape. Okay, because absolute values make a V. So this is the standard, most basic absolute value graph. And you want to just kind of memorize that. Whenever you see y equals absolute value of x, bottom line, you want to just think in your head, you see this equation, and just draw this standard V that goes up 1 over 1 in both directions. Okay, so that is a good thing to memorize, because now we're going to take it and we're going to shift it by adding things to the equation. So now this time we added a different slope, we have a different x value of the vertex and a different y value of the vertex. Okay. Now if you recall from the lesson we had on parabolas, the b causes us to move left or right opposite of the sign. And then the c causes us to go up or down. Same as the sign. These move exactly the same as parabolas. The only difference is instead of making a U, we're making a V. So now we're on this graph. We can figure out the vertex first. We're at -4, so opposite of that is +4, -2. So in other words, I move, instead of moving to the left 4, because the negative would make us think that we're moving left, we move to the right 4, 1, 2, 3, 4, and down 2, 1, 2. Okay, so my vertex is right there, and then I use my slope, which is -1 over 2. So I go down 1 over 2, put my first dot, and go down 1 over 2 again, down 1 over 2, and I can continue to go that direction, and I'm supposed to reflect those points. So I go down 1, left 2, down 1, left 2. And continue to do that forever, and you'll get your parabola. This parabola is facing down. So, and that's okay. That's because there's a negative sign in front. So this parabola is facing down. So the question is how does this move from its parent? Well, its parent is this graph. It's always this original, most basic V. So how did it move? Well, from here, it moved to the right 4, so I would say right 4. It moves down 2, and then it reflected. I would also say it, so if I was actually listing this, I'd say right 4, down 2, and then it reflects. Because notice, instead of facing up like this, so instead of going up like that at this point, it goes down. Okay? So it reflects, that's what that means, and that's because there's a negative sign in front. That's the reflection. And finally, we would say that this has a vertical compression because notice that it's wider here than just going down 1 over 1. Okay? The 1/2 causes it to be compressed. In other words, it's like I'm squishing it this way. There's pressure on it pushing these out. Okay? So that's a compression. Now if it was taller, if you just happen to see one that was taller, like for example if my graph had actually gone more like this, we would call this graph a stretch. Okay? Because it got stretched, it's taller than the original standard graph. Again, this is my standard V. If it's taller than this, you call it a stretch. If it's wider, you call it a compression. So compression is wider. Okay? Now sometimes when we're doing these absolute values, the M per se is on the inside. Notice on this particular problem the 3 is right here. That's kind of our M, but we don't want it right here. We want it actually on the outside. So in order to do a problem like this, what you have to do is treat, and it's kind of strange because technically it's bad math, but technically what you want to do is treat this as a parentheses, and you need to factor out the 3. In other words, I want it to go out in front, but I can't just take it away from this one. I also need to factor it out of the 12. So basically I'm supposed to divide this by a 3 and divide this by a 3 so that I can put that 3 in front. Okay? So hopefully you follow this. We've got this 3 needs to be on the outside over here. So basically to get there I would have had to multiply that by 3 and that by 3. So what multiplied to get 3 here would have been a 3, absolute value just an x, and then this one would have had to have been a 4. So that if I was to multiply this, I would get the 3x. If I was to multiply it by the 4, I'd get the 12. So in other words, divide both of them by 3 and put the 3 out in front. So this is just for whenever you see a problem that has the number in front of the x, right here, and it's not in front of the absolute value. So it's inside the absolute value next to the x. We're not supposed to have a number there. It doesn't work with our, if you look at our original formula, it's supposed to be on the outside. So if it's on the inside, that's when we have to do what I just did, which is divide by that number and pull it out. Now that we've done that, we're ready to go in our formula because we've got our B and we've got nothing out here for our C. So that means our vertex is at opposite of the sign, -4, 0. So this graph moves to the left 4 and it's at 0. Okay, now from there we just use the slope, which is 3. So this one's going to be a stretch. I go up 3 over 1, up 3 over 1, and I connect my dots, and there's my V. Okay, so this would be an example of a stretch where it's taller than the original graph. Okay. Now we're going to do a similar one where we have to do that same thing of getting rid of this 3, but this one's going to be a little bit more complicated. As you'll notice that we've got this 3. Like I said, we have to factor it out. So I want to divide this by 3, and now notice this time it doesn't work as easy. I have to divide by 3 here. Well, it's going to turn out okay, but it's just going to be a little more complicated with the 4/3. So I pull out my 3, so it's going to be -3, absolute value x, plus 4/3. And then on the outside I have plus 6. Okay, so it's still same process, but instead of factoring out the 3, like easily pulling it out, again, this is just demonstrating I technically am dividing by 3 here, dividing by 3 here. Okay, and again, I can check my work because if I distributed the 3, I'd get -3. I'd get 3x. If I distributed the 3 here, I would get just the 4 again. Okay, so what that means is my vertex is going to be at negative, and then 4/3 is really 1 1/3. So 1 and 1/3, you could write it like that, comma 6, or you leave it as 4/3, whatever makes more sense to you. So that means my vertex is over at -1 1/3, about right there, and then up 6. So right here would be my vertex. Okay. Now from there, once I have my vertex plotted, I just have to go down 3 over 1. So down 1, 2, 3 over 1, and then down 1, 2, 3 over 1 the other direction. Okay. And then I just connect my dots, and I've got my parabola. Parabola, absolute value v. Okay? So this is, again, another example where it's more complicated. We just have to pull that number out in front, and then it works just like that first problem I did with the 1/2 in standard form.